There we go. All right, everyone. Sorry about that. A little bit of a delay. I think we're back online. All right, so welcome to the rest of the semester, to the COVID-19 version of CS 125. My main priority today is not to get through content. It's to talk as a community, as a class, about how we're going to get through the rest of the semester. The course staff and I have been thinking about this over break. We've talked about it a lot. We're not sure we have perfect answers for all the questions you might have. We're also not sure that we're going to do this perfectly. This is obviously new to us as well. But we think that, if we work together, we can put together a really useful and valuable version of the class for you guys to continue on with through May. So let's talk a little bit about sort of how exactly that's going to work. I will take questions. The point of this is to really have a conversation, although the time lag makes that a little bit different, but I will be peeking at the topic on the course forum. So if you have questions, please go ahead and ask them there. I'll peek over there periodically, check in and see what's going on, and then come back and we'll talk about things here. Okay. So, the goal today was actually to talk about algorithms. Algorithms is a series of steps that a computer takes to solve a problem. But instead, we're going to talk about how we're going to solve the problem that we're facing, which is that we don't get to be together for the rest of the semester. That really is something that, despite the fact that you can learn computer science online along with pretty much anything else you want to, there are aspects of this course that we've designed with the expectation that we'll be together, whether those are office hours, whether those are our quizzes, whether it's even class, right? I mean, I'm getting used to this new format. I've been joking with my wife. We've been watching some of the comedians that are on now that are broadcasting from their homes. And I'm like, Trevor Noah's not that funny at home either, right? So there is something lost when I'm sort of trying to teach into this little green light that's sitting at the top of my monitor. I miss you guys, and the chance to be with you is something that's really fun for me, and I know that the course staff enjoys that as well. So we need to figure out how we can best manage what we're trying to accomplish together, despite the fact that we're losing this ability to spend time together and to be close to each other, and that's going to be tricky. But here's kind of what the plan is. I am not set in stone on any of this. I'm certainly open to suggestions, but this is our best guess at a good way to go forward together. All right. And keep in mind, our goal. So what's the desired end result here of this algorithm? It's not about this semester. This semester is odd. This is a strange, weird time. It's a weird time to be alive. Certainly a weird time to be in college. Weird time to be doing anything. It's just strange. It's unnatural. It's stressful. Anxiety-provoking, and a little bit just overall weird. But our goal here is to prepare you for the future where things will be normal again. You will get to courses that depend on CS 125 as a prerequisite, or you will go off into the world and you want to do things with computers, and you will, need and want to have a foundation on this knowledge, and particularly the stuff that we're about to talk about, because unfortunately, kind of this crisis came into play right as we get to the part of the course where we really get to talk about some cool stuff. And so I'm really excited about this, despite the fact that we'll have to do it separately. But our goal here, again, is to build a foundation for you that you can then take forward into your other classes, and that's going to support you in your studies in computer science or whatever you decide to do in the field in the future. We also, however, want to take care of you this semester. So these are our competing objectives. This class, produces a little bit of stress. I understand that. Right? I think there are some things coming that might help mitigate that, which I'm excited about. But that's something that we're also aware of, right? So, we don't want to overcorrect here and try to do too much remotely and virtually, given the fact that some of you are in different time zones. Some of you have family obligations to take care of. Some of you have, family members that might be sick or might get sick. We just don't know what's going to happen. So this plan is also certainly subject to change. If things change on the ground, if things get way worse or things get a little bit better, we'll adjust as needed. But these are our competing objectives, right? And I'm not sure they're entirely competing, right? In the sense that I think the better job we can do taking care of you this semester, the better place you'll be once you get downstream and you get to courses later on and into the rest of your future in computer science. I mean, CS 125 is really designed as a starting point, right? We want to launch you out into the world in a good way. And hopefully you'll succeed in later courses. And then they'll seem easy, and you'll be like, that CS 125 class, whatever, that wasn't that important. That's kind of what we're going for. Our desired result here is that you learn computer science, right? Again, we want to take care of you. We don't want to add too much additional stress. I know this is a stressful time for everybody, but we do want you to learn the material, right? Particularly if you're going to go on to other classes. All right, so here's what we're going to do to try to modify our normal algorithm, right, given these new constraints, to try to continue to achieve our end goal, which is that you learn computer science. A lot of the parts of the course are going to move forward pretty much as planned. What I'm going to focus on today are the adjustments we're going to make to a couple of places where we really do rely on being together. We rely on having you either go to a specific place like the CBTF, or we, some of you rely very heavily on coming and being able to spend time with the staff in office hours, right? So we're going to talk about those. Those are places where we needed to make some adjustments. We're going to have to try some new things. But there's a lot of the parts of the course, the homework, the MP, that are essentially going to continue forward, right? We're going to ask you to do a final project. I think that'll be a fun coda to the semester like it normally is. We won't get a chance to do the project fair, but we will do a project. I will get to quizzes, don't worry. You guys can welcome to peek ahead on the slides, right? We're going to talk, I'm not in a rush today. There's a video up from last semester you guys can watch with the content that we need to get through. So if we end up spending the entire hour talking about kind of how we handle the rest of the semester, I think that's worth it, right? We'll see how it goes. All right, so the things we need to make adjustments to, I think, primarily are, quizzes and office hours. Those are the two big things that are going to receive a lot of attention or just need a different approach. And then also we'll talk a little bit about how we're going to adjust some of our participation expectations, given the fact that you guys are all over the place now. Okay, so here's how we handle how we plan to handle some of the places where we used to meet, right? We used to come together either synchronously for class, sort of somewhat asynchronously for the quizzes or office hours, okay? So I'm going to keep live streaming Monday and Friday at 10 a.m. On Wednesday, you're going to have a video lecture to watch, and I'll talk about why in a minute. But our class time on Monday and Friday, we're going to continue to have. I hope many of you are in places where you can join us. I think this will be fun. To the degree that we can get together as a community, that's one of the times that we have to do that. But I'm going to continue to go through the material in front of the live audience. I'll try to find better ways to take questions along the way and stuff like that. I'm getting these little notifications from Discourse, which is pretty cool, so that helps. And so again, on Wednesday, I'll post a video lecture. Sometimes that'll be from previous semesters. Sometimes I'll record something new for this semester. It kind of depends on where we are. I'm going to try to kind of keep pace with what we did last semester. So labs, okay? So labs, obviously a place where you guys used to come in. Not doing that anymore. Instead, what we're going to do is we're going to open up the labs that have activities, which is kind of most of the ones for the rest of the semester. There's a couple where we're going to give you some time to work on your final project. And in those cases, you'll have the time, right? The other labs, what we'll do is we'll kind of open them up. They'll just be another homework problem, essentially, right? That's our plan. We'll see. Maybe we won't do them, but that's our plan right now. Open them up. You guys are welcome to work on them together, to collaborate with each other, whatever. The TAs and the lab assistants will be running virtual office hours during the times that you would normally have lab, but there is no need to attend at the time that you would have normally had lab. I know that some of you are time gapped. We'll talk about that in a little while. But hopefully that 24-hour period gives you plenty of time to get to the lab activity and enjoy it and complete it. Okay, office hours. So this is one of the parts of the course that we're going to work on hard because I know it's super important. So, I think one of the things that I'm appreciating, maybe because of this crisis, is how valuable it is for us to be able to spend time together. When I took over this course a couple years ago, it took me several semesters of pleading and cajoling to convince the department to give us that room in the basement that we now use for office hours, right? In the past, we had this tiny little room. It was like the size of a faculty office. And, you can imagine the number of people that are down there getting help from our fantastic course staff trying to cram into this tiny office. People were like slumped against the wall and like lying on the floor. It was bad. So we got our own room. It's the worst room in the entire building, but of course now it's empty along with the rest of CETA. So this is a part of the course that I spent pretty much the entire break working on. I'm not completely ready to share kind of what we've done, and we'll see if it works, and we'll see what some of our other staff have come up with, but we are putting staff energy, time, and resources into figuring out how to do this, right? We have people that want to help you, okay? That didn't go away, right? The course staff that are really one of the best parts of this class are still there. They're still out there in the world, distributed all over the place. They still want to help you. They still care about you and about your future in computer science. We just don't have a place that we can all meet up. So we're going to try to build that place online, virtually, and try to get it to work, I think, as seamlessly and as effectively as our office hours do normally. Now, I'm not pretending that this is going to be a replacement, because there's something that you get. There's some sense of community and fellow feeling and just positive vibrations that you get from coming into, well, I don't know how positive they are, but some sort of vibration from coming into the basement, sitting down next to people that are frustrated with the same things you are, and building that sort of community, right? So I can't promise that we can replicate that online. We're going to try. We'll do our best. But, just keep in mind that you might need to work a little harder online on the forum to kind of reach out to people and get some of that community that you were getting from coming to office hours, from being around other students and staff of the course. There's something very powerful and meaningful about that I think will be lost online. We'll work as hard as we can to replicate the sort of aspects of office hours where we're helping you. But in terms of you guys feeling like you're part of a group, feeling like you're part of a team, feeling like you're part of a community, realizing that other people are struggling with the same things you are, and getting some support from that, that's something that we're all just going to have to be aware of, right? So again, I'm well aware that this is a concern. A lot of the responses to the feedback form mentioned office hours. I've gotten a bunch of emails about office hours. We are aware that this is going to be something that's going to be tough, and we will correct for it, right? I also want to point out that to the degree that this affects your ability to complete other parts of the class, we'll also take that into consideration as well. We'll get to talk about grading in a few minutes. Okay, so assessments, right? So that's sort of the meetings, right, when we got together. What are we going to do about assessments? So here's the plan with quizzes, okay? We're going to move the quizzes. Obviously, we have no equivalent of the CBTF, right? And again, something that I sometimes take for granted, although I do tend to tell people more than they want to hear about how wonderful the CBTF is. But this is something that we don't have. And so the best thing we can do is we're going to run the quiz during class time on Wednesday, okay? If you are time gapped, we'll talk about that in a minute, right? But for most of you, I suspect you will be able to virtually attend this quiz, right? It's the same format as in the CBTF. It's going to be on Prairie Learn. It'll open up at 10 a.m. You'll have 50 minutes to complete it. Obviously it's not the same environment as the CBTF. We'll talk about that in a few minutes, but this is the best that we can do, right? I know you guys tend to hate on the CBTF, and I get that. It's a place where you have to go to take a bunch of quizzes, but it really is a pretty special educational tool, and there's just really not a replacement for it. So this is what we're going to do. So again, on Wednesday, rather than have class, we will run our weekly quiz. And that'll start, I hope, on Wednesday. Although, if we don't get to it this week, it's really not the end of the world. But I kind of like to do it to practice because you have a midterm next week. All right, so participation. So lab participation is going to basically stop. We're just going to stop calculating it. The rest of the semester, the lab participation is ignored. So whatever you've got, you're going to keep, okay? Some of you may not like that. We can talk about it more, but that's the plan. Lecture participation, we'll see, right? We're either going to do one of two things. Either we'll just approach it in the same way as lab participation, where we just kind of freeze it where it is now, or those of you that can join class synchronously will get participation during that time. And then I'll provide like one other window of time where you can watch the video, follow along at home, and receive participation credit. And that'll be at a time chosen to accommodate people who are in vastly different time zones. Anyway, I haven't kind of made a decision here, but we'll figure this out. The MP homework and final project, we're going to continue. The homework, I don't see any reason to make any changes to that. We will keep an eye on how things are going, and we're going to find new ways to help you guys with that virtually. The MP, same thing. So we're definitely adjusting MP difficulty. That was something that we were doing anyway this semester before this crisis. So it's something that we're going to continue. The final project, I think, is actually one of the most valuable parts of this class. So we're definitely going to do that. The assessment for the final project has historically been extremely generous. That's not going to change. We'll talk more about the final project in a couple of weeks. Unfortunately, we won't be able to have a final project fair. Projects with your lab, get feedback on them, and receive a grade for that part of the class. Okay, so let me talk about, so the biggest place where I think we need to make exceptions is if people are, on the other side of the planet. Okay, so if you're in a place where you're like 12 hours or 10 hours off from Central Standard Time, then we will have a way for you to get in touch with us, and we will make accommodations for that. Probably what that's going to look like, main place we need to do that is for the quiz. You'll have a different time slot to take the quiz. I'm not going to give it all day for obvious reasons. We'll probably give it in 2 different time slots. If you sign up for that, you have to take it at that time slot for the rest of the semester. Okay. Maybe that's a restriction, that's a little bit whatever, but that's how we're going to do it, right? Now, again, if you're just like, I don't want to get up early because it's 8 a.m. on the West Coast, then maybe not so much. But we're really looking at cases where people are like 8 hours, 10 hours, 12 hours off, right? Where, I don't expect you to get up in the middle of the night to take a quiz, right? It's not going to put you at your best, right? I want you to have a time to take the quiz where you can do your best, right? And so I think we should be able to find 2 time slots, our normal time slot and some other backup time slot that we'll use to make sure that everybody has a chance to take the quiz. Now, again, some of you may have to get up and take it first thing in the morning. Some of you may have to take it late at night, as long as it's not in the middle of the night, like 4 a.m. or something. We do need to work together here because people are kind of all over the place, right? But if you need this form of accommodation, please fill out the form and we'll put you on the list and we'll get in touch with what exactly the procedures are for that. Okay, so the university is still dragging its feet on this. I don't know why. I suspect that I've seen some indications that pass-fail grading this semester is something that is going to be an option for instructors. If provided that option, I will use it. And so we will convert the course to pass-fail grading. To me, this is a kind of a no-brainer, right? I don't want people in this class this semester to be stressed out about the difference between an A and an A minus. Right? It just doesn't matter. It's not important right now. And I think also this will reduce maybe some of your concerns about our ability to secure some of the assessments that we would normally able to do in a little bit more of a secure fashion, right? So again, it looks like that there are a couple of different options here. I don't want to bore you with the details, but it looks like the university seems to be moving towards, and maybe there's a mass mail that I haven't received or whatever, but it looks like the university is moving towards being giving instructors the option to change their course midstream to pass-fail grading. And again, if that is an option that I have, I will use it. And I think, again, that'll just allow everyone to relax. Those of you that are, the people that worry about the grades in this class are not the people that fail. So those people will have one fewer thing on their minds and be able to just kind of focus on learning the material and building a foundation for downstream courses. That is our goal this semester. Not differentiating between the A pluses and the A minuses or whatever. That's just not that interesting. Okay, let's talk about cheating. I just want to acknowledge this because I know it's a thing, and I don't have any magic bullets here, right? So we are going to give the quizzes online in a synchronous format. There is nothing. I'm just going to be honest here. There's no point in me pretending or trying to scare you or whatever. There's really not anything that we can do to prevent you from cheating on the quizzes, okay? So there it is. It's one of the reasons that I'm hopeful that we'll get the pass-fail grading system in place. Maybe that'll make people a little bit less desirous of doing this, okay? So here's the thing, right? We're going to continue to check for cheating in other parts of the class the way that we normally do. But I think given the type of situation that we're in, we kind of have to trust each other, right? We have to work together. I think, I don't want you to feel, and I hope you have never felt, an adversarial relationship with me or the course staff, right? We are not enemies, right? We are all working towards the same goal, right? And I know that me and the course staff will be working probably harder than ever this semester to try to achieve that goal, which is we want you to learn computer science. We're all in this together, right? It's not us versus them. There's no us and them. It's just us. And so, again, I just want to be frank about this. There's not anything I can do about it. If you want to cheat on these quizzes, you can. I don't think that that's a good idea. And I hope you won't. I hope you won't, because that is something that will really end up having a negative effect on your ability to succeed in courses in the future. If you cheat this semester and you don't learn the material, you will. So here's the thing. This is, like I said, this is a strange time, right? This is a weird semester. But there will be normal semesters in the future. And for those of you that are taking this class and want to go on to do other things in computer science, you will find yourself come back to normal. And at that point, if you obtain the knowledge you need in this class, and if you don't cheat on the assessments, and you learn the things you're supposed to, you will be in a good place. And if you don't, you're going to struggle, right? So again, this comes down to being about the future, right? If you want a future in computer science, you have to learn the material. That's how you do it, right? Whether that future is in courses in our department, or that future is in industry, or that future is as a hobbyist doing cool stuff, this is how you get there, right? And if you cheat, all you're doing is basically just, putting yourself at risk, right? You don't know something you were supposed to know. The other thing I want to point out is that, particularly, and I'm very much crossing my fingers about this pass-fail grading stuff, but if we go to pass-fail grading, then hopefully we start to see the assessments in a very different way, right? The assessments don't exist to, put everybody down into these very finely graded boxes on a grading scale. That's not the point. The assessment exists to provide feedback to you about whether or not you know the material or not, right? It's like if you're trying to learn a foreign language and you go and talk to a native speaker, right? If you can speak it, you can have a conversation, right? That's a real assessment. That's kind of, the proof is in the pudding, right? If you cheated on all of the exercises you were doing as you were trying to learn the language, and you get to the foreign country and you can't speak to anybody, then it's like, there it is, right? So there is a reality in the future that you guys need to prepare for, right? This is a semester where I think we're going to try to come together and take care of each other, and maybe we're all going to acknowledge the fact that we're under a lot of stress, right? And there's a lot of anxiety producing stuff out there that everybody is dealing with. I don't want you to worry about cheating, right? But I also don't want you to cheat, right? Just do your best work. And I think if we all trust each other, we'll get through this together. All right, let me scroll over to the question thread. Yeah, so, where'd it go? Okay, so there's a question about MPs. So there's no plans to add MP drops. I don't think we'll need them, right? Again, some of these great course policies that we've had in the past are really designed to kind of help ease some of the anxiety for people about which grading bucket they're going to end up in, right? A dropped MP, I don't think, I have a couple semesters with the data I could look at, but I would be shocked if a dropped MP has ever made the difference between somebody failing this course or not, okay? It just, the people that are failing are not in need of an MP drop, right? They're in need of doing the MP at all. So, but on the other hand, if this would be something that would help you guys feel a little bit less anxious and enjoy your work in the class more, I'd be willing to consider it. But again, to the degree that we can get to a pass-fail grading system, I'm hoping that some of these measures won't be as important, right? Some of the smaller things that we've done in the past in the context of a letter graded system, I think might just be, you can think of pass-fail as the ultimate drop, right? You can drop anything as long as you don't drop below that pretty low bar, right, that you have to clear in order to pass the class. I don't. The question is about letter grading. Again, and I don't know how this will work, right? But I think if I have the option, I will make the class pass fail, right? Meaning that there will be no letter grades assigned, right? I don't, that's there may be another option where students can choose credit, no credit. I would prefer that we make a decision, and I think this is a decision that I would make, right, on behalf of the class, because I think it's the right decision to institute the pass-fail grading system, right? I just think there's way more in this in the situation that we're in to be gained from that than there is lost, right? Look, no one's going to forget this semester, right? It's not like you're going to give your employer a resume and they're going to be like, wait, spring 2020, like, why did you get a pass in CS 125? I had a student next semester who got an A. It's like, dude, you were there, right? Like, no one is unaware of what's happening, right? I mean, spring 2020 as a semester will always have a massive asterisk next to it, right? So I just wouldn't, if that's where the concern is coming from, like, oh, I really need to get an A or whatever, whether it's transfer into CS in this department, whether it's academic employers, whether it's whatever, the pass-fail grading is for this semester is not, no one is going to look at this semester as a normal semester, right? And again, I think our goal with moving to pass-fail will be to say, let's focus on the learning outcomes for the class, right? And achieving those rather than, having students worry about grades. This is particularly important with respect to cheating, right? Like, I don't want people cheating on the quizzes because they're trying to get an A, right? When those students would have learned more if they had just been like, I'll just relax, right? I'm going to get a P, I'm well clear of a P, so I'll just relax. I'm going to do the quiz on my own, do my best, and if I don't do as well, maybe I've learned something about what parts of the material I didn't understand as well as I thought. Okay, let me go back. Yeah, we'll definitely add, we'll add people to the time gap list as needed. Yeah, so I don't know. I mean, the pass-fail, we'll keep talking about that. There seems to be a couple of comments on that. Maybe we'll run a poll of the class to see how people feel about this. I am going to exercise a little bit of executive judgment here in terms of making a decision that I think is in the best interest of everybody, right? And that includes some of the people that were struggling in the class, some of the people that were heavily reliant on office hours, some people that might be dealing with so that's the other thing I think we all need to keep in mind, right? Being on campus is not entirely completely normalizing because there's always stuff that people are going through, whether it's personal things or psychological challenges or physical challenges or whatever. So we're not all living the same lives even when we're close to each other on campus. But I think when you scatter everybody to the four winds and send people back home and stuff like that, I suspect that the disparity in the type of challenges that people are facing is quite a bit different, right? So remember, some of you are in places that have great internet access, some of you aren't, right? Some of you are in places where you can kind of focus on doing your own thing. Some of you have family to help take care of, community obligations. Some of you have financial security right now, which is a real blessing. Some of you don't. Right? And so I think that given all of that difference in perspective and difference in experience, I think that the pass-fail grading option makes more sense. MP3 will be out today. Putting the final touches on it. It is easy. If it's not as easy as we thought, we'll make it easier, but it should be fairly straightforward. We're getting that out the door. I didn't want to release that over spring break. I just wanted to let people kind of breathe, think about, what comes next, work, with their families to figure out, sort of what their situation is for the rest of the semester. Maybe get your stuff out of housing or whatever. I'm rolling my eyes at university housing. It's like, just let people leave their stuff there. Who cares? What is it going to hurt? It's not going to go anywhere. Maybe somebody had like a pet tiger or something they needed to go take home. But anyway, so MB3 will be out today. We'll release it this afternoon. All right. Well, the MP deadline changed for I think this is Ben's gonna have to remind me, but I think this is a 1 weeker, so we might just make it the same for everybody. It might just be Monday night. On some degree, we'll have to see how this goes, right? But on some degree, given, the new office hour approach, I think we'll still stick with the teaming idea. For the remainder of the semester. There's only a couple more MP deadlines that we have to get through. So once we're through those, things will, we'll get to the project, and that's kind of basically 3 points. So, all right, I'm gonna linger in the question thread for 1 more minute just to see if anybody else has any questions. I know that I'm a little lagged. Okay, so let's go on and talk about some actual computer science. So this is, again, in many ways, not just material-wise, but this is kind of a turning point in the semester, right? So you guys went on break. We spent, up to break talking about object-oriented programming, and now we're moving into the third half of the class, which is about algorithms and data structures. And this is the best material that I've got. Right? This is it, right? Everything that we've done kind of has led us to this moment where now we can actually start to appreciate some of the power and beauty of computer science, right? Because algorithms really are the conceptual core, right? This is computer science, right? Everything else is just kind of like built around it, right? And we have a lot of support infrastructure around just some fairly simple algorithms, right? But this is, if you think about a conceptual core of computer science, it's algorithms. How do we have a computer solve a problem, right? And, one of the things that's so interesting about computer algorithms that you guys have been finding out as you've been working on computer code is you have to be very, very, very specific, right? And so to some degree, because computers are so literal, because computers make us be so specific about how we solve a problem, that means that once we've instructed a computer how to solve the problem, we have a very good solution. Because if a computer can execute it, then we must have specified it very clearly, right? And essentially, the building blocks that we use to implement algorithms are things that we've already talked about this semester, right? And this goes back to the first half of the class, right? Our imperative programming basic building blocks, right? Performing simple calculations, math, storing results, and then making simple decisions based on the computations of data we already have. And then we repeat this process sometimes. It loops over and over as fast as we can, right? So data structures, I think of this as the algorithm and data structures component of the course. And you're going to see why as we go on, right? A data structure is some way of structuring data, right? Putting data in relationship to other pieces of data in some way that's intended to help us solve a particular problem, right? We've built up here as well, right? This builds on some of the stuff we talked about in the object-oriented components of the class. So at the beginning of the semester, we talked about, how we use primitive types. And then when we got to the object-oriented component of the course, we looked at how we can use objects to model data that's arranged in more complex ways. We've looked at existing data structures like arrays. And now we also talked about references. So now we have ways of essentially defining new relationships between two objects using references. And that's something that we're going to build upon as we talk about some of the more complex data structures that we'll look at throughout the remainder of the semester. So these two topics, we have a course on data structures. I think it should be a course on algorithms and data structures, right? There are courses in algorithms. I think this course should be on algorithms and data structures. These two things go hand in hand, right? They are very, very closely intertwined with each other, right? The main reason is that so you might think, well, I've got an array. I already have a way of storing multiple data values. I have an object, and so I can kind of group different types of fields together to model something that has a little bit more complicated pieces of data that go along with it. Why do I need other data structures, right? And the typical reason that we build a new data structure is because it allows us to implement a particular algorithm more efficiently than we could using a different data structure, right? So I can store everything in arrays, but there are certain algorithms that don't work very well on arrays. They run slowly. And so data structures and algorithms are complementary in the sense that frequently when we build data structures, right? So when you go on and you take 225 and you learn about all these cool data structures, really the course spends a lot of time talking about algorithms, right? How do you do a search on a particular type of a tree? Search is an algorithm. I'm looking for trying to determine whether or not a piece of data exists in a group of data, right? The tree is the data structure that allows me to perform that search quickly, right? So these things are very, very tied together, right? When we implement data structures, and we will do this throughout the rest of the course, we'll talk about the specific algorithms that they're useful for, right? And this is, one of the reasons why this part of the class is so fun is not only does it give us a chance to talk about some of the deep conceptual concerns of computer science as a field, but it also gives us a chance to stretch our legs with the imperative and the object-oriented programming. So we're going to use all of those concepts, right? And we're actually going to start to see them be useful, right? We've sort of been studying them in this abstract way, particularly with objects, right? But now when we get to data structures, we're going to put those object-oriented principles into action. We're going to see interfaces at work. We're going to see references at work, right? We're going to build objects that allow us to model simple data structures, right? So this is really cool stuff, right? And we'll introduce some really new important ideas, particularly related to algorithm analysis, right? Because remember what I said before, once we write an algorithm down so that a computer can actually execute it, we've provided a very, very precise implementation of how to solve a problem. That precise implementation can also be studied, right? And we can also then sometimes even prove things about how long it takes to run and how long it takes to run, meaning to solve the problem, right? And this is something that you may have heard of already, you may be familiar with this. This turns out to be a pretty important building block in a lot of number theory applications. So the idea is, if I have two or more integers, I can actually find the GCD of an arbitrary number of integers, but let's just imagine it's 2. Then the greatest common denominator is the largest positive integer that divides all of the integers evenly that I've been given, right? And there are when we talk about algorithms, there are usually multiple ways to solve the same problem. And with GCD, there are some very sophisticated algorithms that you can find, including on the Wikipedia page, for solving this particular problem, right? And some of those, when performance is really important, right? These sophisticated algorithms may work really well. But for now, let's talk about a simpler approach that we can use to begin to build up our intuition about how to analyze the performance of algorithms, okay? So if I've got two numbers, so this brings me to kind of a general problem-solving strategy, right? So when we talk about algorithms, we frequently want to compare them with the most basic way of solving the problem, right? This is sometimes known as a brute force solution, okay? I used to review papers by somebody who had this kind of amusing habit of referring to this as a brutal force solution, right? The goal is not to kill the problem, right? The goal is you're sort of acting like a brute, right? A brute is, what does a brute do, right? A brute is strong, but not smart, right? In the sense that when a brute tries to solve a problem, it just kind of like applies all its strength and then finally, it manages to lift the thing or whatever. So there are actually some problems that you do need a brute to solve, but this is not one of them. But we're going to come up with a very, very basic approach that takes a long time, but we know will work, right? And this is something that, again, we'll come back to when we talk about other algorithms, because it's frequently useful to think like, what is the most basic way of solving this problem? And then you can think about why the more sophisticated algorithm that you're studying does better, right? So this is sometimes referred to as a straw man, right? It's an approach that will work, but it doesn't work well in the sense that it's slow. So a brute force solution frequently works by basically just systematically checking all possible candidates in a fairly unsophisticated way, right? Now, here's the thing, and this is something that's going to kind of haunt our discussion of algorithms. Computers today are so fast that brute force solutions sometimes will work fine, right? And sometimes brute force solutions are even the right solution, right? When performance doesn't matter, right? Unfortunately, this can also sort of, I don't want to use the word that came to mind, but this can color our discussion of algorithms, because sometimes when you're running on a modern computer, even a really dumb way of solving a problem, when the problem is small, is so fast that you think, oh, that must be fine, right? like that's a perfectly okay way to find the GCD, right? I ran it on my computer and it ran like that. We'll see. This is fast, right? Our brute force solution to this problem is going to be really fast. The problem then becomes, when the problem gets really big, these types of unsophisticated solutions get very slow. And so when you go, I mean, if you're just playing around on your laptop with some data sets, you'll be fine, right? But then you go to Google or Facebook or, the big tech companies that are studying the COVID-19 virus or whatever, and you've got to operate on massive data sets, right? Now this gets slow, right? And now this becomes, the difference between, getting an answer in a week and getting an answer in a day, getting an answer in an hour, getting an answer in a minute, getting an answer in seconds, right? Those differences make a huge difference, right, in terms of how we solve problems. All right, so let's try to implement a GCD function. This is going to be a static function. This gives us a little bit of practice with our imperative programming skills. So I'm going to write my public static function. This is going to return an int. I'm going to call it GCD. It's going to take 2 integers. Again, you can provide a more generic GCD algorithm. One other thing about this I'm pretty sure that checkstyle is going to be mad at me about this. Let's just fill in a little, yeah, okay. We're going to call this GCD to avoid angering the checkstyle gods. See, I just leave these little Easter eggs on here just for fun. Okay. So let's think about, and again, if we were live together, I would ask you to sort of think about walking through how to solve this problem, right? So I've got 2 numbers, and the goal is to find the greatest number that divides both of them evenly, okay? Now let's think about some properties that number has, right? So the greatest number that divides the 2, if I have 10 and 8, right? The greatest number that divides the 2 evenly can't be bigger than 8, because nothing bigger than 8 will divide 8 evenly, right? By divide evenly, we mean it divides it and leaves a 0 remainder, right? So I know that the largest number that I have to check is the smallest, right? It's the smaller of the 2 numbers. So let's do that first. Let's figure out the smaller of the 2 numbers. So we'll say int smaller is equal to first, and then if second is less than first, we'll set smaller equal to second. And for now, let's just return smaller, okay? Just to make sure that this basic building block of our program is working the way that we thought, okay? All right, so that seems to be working properly. Okay, so now we know the largest number that it could possibly be, and we also know something else. So that there is a number that will always work, right? So 1 is a common denominator of any 2 integers. So any 2 integers will be evenly divided by 1. It's not the greatest common denominator, right? It's the smallest common denominator, right? And so if I asked you to find the smallest common denominator, you just return 1, right? You don't even need to do any calculation at all. So I know the smallest can be 1. The largest it can possibly be is the smaller of the 2 numbers. And so my algorithm, again, the simplest possible algorithm is, let's say, I'm going to check numbers, and I'm going to check numbers starting with the smaller of the 2. I'm going to continue while my candidate is greater than 1, and in each step, I'm going to reduce my candidate by 1. So now if I'm checking 8 and 10, I start with 8. So 8 might work. If 8 works, then I'm done, right? And I know it's the greatest because that's the largest number that could possibly work. If 8 doesn't work, then I try 7, then I try 6, then I try 5, then I try 4. And eventually I'm going to get to 1. Now my loop here doesn't even get to 1. It actually stops when candidate is 1, and that's because I always know that 1 will work, right? And here I also need to do something else, which is I need to declare my variable outside of the loop so that I can return it. And then I'll do a slightly different for loop. Okay. Now, how do I check, right? So remember, this is a brute force solution. I'm checking every candidate, right? The way I'm going to check is I'm going to use the remainder function. So I'm going to say if first candidate is equal to 0. So if it divides the first number evenly and it divides the second number evenly, then I'm done. I found my number. Okay. Otherwise, I keep going. And eventually what's going to happen is I'm going to, and actually, you know what? I could just do this. Let's rewrite this again. Because I don't need to know what the candidate is, because I'm going to return it immediately from the loop. Okay. So this works, right? You'll see, and you can verify this yourself. For 10 and 8, the greatest common denominator is 2, right? This one you can think through. 4 doesn't work because it doesn't divide 10 evenly. 8 doesn't work, doesn't divide 10 evenly. 2 works, right? 150, 50 is actually the greatest common denominator, so I stopped right away. These two numbers, though, are sometimes what's sometimes called relatively prime. They have no factors in common. So I started with 65270, and I went all the way down to 1. And along the way, I didn't find a single number that divided these two evenly. Okay, so we are out of time for today. Here's what we're going to do. I am going to post there's not much left actually to talk about today, and we'll come back and we'll cover some of this stuff on Wednesday. I'll actually go through Wednesday slides and see if there's anything you guys need to review from today. I think actually on Wednesday I come back and I end up talking about a lot of this stuff again. So it's possible that that's what we're going to do. Okay, so, again, today I hope we had a reasonable starting point of how to kind of make the best of the rest of the semester. I do want to hear from everybody. We've been going through the feedback that we received through the forum that we give you extra credit. We will give you extra credit points for. If you haven't filled that out yet, it's still available, so please let us know. There's definitely some common themes that have emerged, but I'm really appreciating the feedback you guys provided. Thank you for doing that. On Wednesday, so again, on Wednesday, we will not have a live stream. Instead, we will open up the Prairie Learn quiz on interfaces at 10 a.m. and we will close it 10 a.m. Central Standard Time, and we will close it, Central Daylight Time. I think we're in Daylight Savings Time, right? So 10 a.m. CDT, and we will close it at 10:50 CDT. If you are far away in another land and you want to take it at a different time, we'll have a form that we send out today to collect your information, and we will offer it to you at a different time. I don't know what to say. We're going to do our best this semester. I really appreciate you guys being patient with us. Let's really try to feel like we're all in this together. I think if we work together, we will achieve the goal, which is for you guys to learn this material. And we'll try to make it as fun and as interactive and as engaging and as effective as we can along the way. So I will see you guys again on Wednesday. I won't see you on Wednesday. You guys will have the live stream or whatever. I will see you again virtually on Friday. Best of luck on Wednesday's quiz.